Okay, so let's take a look at some more of these trig identities where we want to actually prove that the identity really holds. So let's take a look at this one. How about cosine squared x minus 1 all divided by cosine x, and that should equal minus tangent x times sine of x. Let's see if we can prove that. And again, the way I think about this is sort of drawing a line in the sand. Maybe I'll draw the line a little bit skewed so I have more room to write. Still a line, not straight. And the idea is I just work on this side, I just work on that side, and hopefully at the end of the day I should have two equal quantities. So let's see how this might play out. Well, you look at this, there's a variety of things you can do, but whenever I see a cosine squared x and a 1 or minus 1, I'm immediately thinking about the Pythagorean identity. Sine squared plus cosine squared equals 1. In this case, I have cosine squared x minus 1. So what does that equal? Well, I've got the cosine squared x. If I bring this over, I have a minus 1. So what does that equal? Well, I take this sine squared and bring it over to this side. So I see that cosine squared x minus 1 equals minus sine squared x. So I have minus sine squared x. So let's put that in on the top. So this equals minus sine squared x, all divided by cosine x. Well, it still doesn't look like this, but what I do see, the minus signs, by the way, look very good. I hope you see that the minus signs make me very happy, because that looks good. Well, sort of a pattern recognition thing now here. Let's write the sine out as just sine x times sine x. I divide that by cosine x. And this sine x divided by the cosine x, that can be combined to be what? Well, that's just tangent x. And then I still have that sine x out in front. And voila, I see that this left-hand side is identical to the right-hand side. So this equals that, equals that, equals that. So these two things are equal. So I just proved that identity holds by just manipulating the side using trig identities. All right, let's try one last one. One last one. This is sort of sad for me because I love these things. All right, how about 1 over tangent of theta plus tangent theta? And I want to see if that really equals secant theta times cosecant theta. So secant theta, cosecant theta, does that equal 1 over tangent theta plus tangent theta? Well, how would you proceed here? Well, again, what I do is I sort of draw a line in the sand, and I'll start massaging the sides if necessary to see if I can make them look the same. Well, you could get a common denominator here, which would be tangent theta. So I'd multiply top and bottom. The bottom here is an invisible 1. Top and bottom by a tangent. I have tangent squared over tangent. And then use some trig identities, use it with tangent. That's fine. But I always use the same pathetic method. I convert everything to sines and cosines. Sometimes I may be losing ground here, by the way. I'm not saying this is always the best method, but it's a method that always works for me, and I'm happy with it. 1 over tangent. Well, tangent is sine over cosine. So when I flip it, I get cosine over sine. And then I add tangent, which is sine over cosine. Okay, now I'm going to get a common denominator, which will require me to multiply top and bottom here by cosine. So when I do that, I'll see a cosine squared theta divided by sine theta cosine theta. And then I multiply top and bottom here by sine. So I see a plus sine squared theta divided by sine theta cosine theta. And now the bottoms are the same. I just add the tops, and I'd see cosine squared theta plus sine squared theta, all divided by sine theta cosine theta. But what's cosine squared theta plus sine squared theta? Well, that equals 1. That's the Pythagorean identity. Cosine squared theta plus sine squared theta is 1. So in fact, this is just 1 divided by sine theta times cosine theta. So that's this side. Now what about this side? What does that equal? Well, this side, let's see, what's the cosecant equal? Cosecant equals, well, just 1 over sine. So this piece right here, this equals 1 over sine theta. And what's secant? Secant is 1 over cosine. If I multiply, I get 1 over sine theta times cosine theta. And look, once again, we get to that moment in my life during these problems that I just get really excited, really excited. 1 over sine theta cosine theta, 1 over sine theta cosine theta, these two things are equal. Well, since these are equal, that means that these are equal, these are equal, these are equal, these are equal, these must be equal. So I actually prove the identity by working on this side, working on that side, and getting two quantities that are known to be equal. Notice the key thing to remember here is I can't use this as an identity. I can't add to both sides and divide both sides and stuff because I don't know its identity yet. I have to prove it's an identity by using just manipulations on one side and the other and showing that they're actually the same. This is what we consider proving trigonometric identities, and I got to tell you, I love them. I hope you love them too. Actually, they're pretty fun. They're sort of like mind games. Try these mind games and have some fun on your own. See you later.